You guys don't know my story. Okay. But yeah, it's surprising that I can smell the level of foulness in this room is all. So I know if I can smell it, I know it's really bad for you guys. Okay. So, coverage. What we will cover. Amazon's Web Services, AWS. We'll talk about the window around 2010 where cloud started to become adopted widely, why businesses needed it. And then on Wednesday, we'll do some of this other stuff. Cloud attributes and service models and how you might go about selecting a particular cloud service. So, in case you didn't know, Amazon has the largest cloud operation in the world, in the sense that it's one that's open for the public to use, right? Arguably, Google and Facebook in their own way are bigger. People use them, but Amazon is one that sells that service to people, whereas Facebook and Google, it's basically free. So, current state, we have a couple of different models, but over here, Amazon, across all of them, is over 30%. Microsoft is about half that. We've got some of these other bigger players, you know, less than about a quarter of Amazon's size. So Amazon's, you know, the really big one. So 2018 cloud service revenue is about $25 billion Amazon made from that. So it's about 10% of its overall revenues and over 30% market share. The next biggest three are, you know, a little less than what Amazon has. And the next biggest 10 are actually substantially, altogether, are substantially less than Amazon. Interesting thing, Amazon got into cloud kind of accidentally. So around 2000, Amazon was building all these tools to help retailers sell stuff through Amazon. At that point, it was becoming a headache for Amazon. They were dealing with so many vendors and they were designing so many custom interfaces to allow vendors to sell stuff through Amazon. They said, wow, this is a big headache. We need to just standardize everything. We need to tell vendors, here's the interface. You don't get to do a custom one. You just make your inputs fit our standard interface. At that point, right, they started being able to reuse a lot of these components, which means that essentially everything in its system started to become more modular. So it didn't matter what vendor was trying to contact Amazon, they were doing it the same way, they were just sending different kinds of data. Likewise, it didn't really matter what server the vendor's data was stored on, because it went through a standard interface, and to the vendor it all looked the same. So that kind of standardization was the foundation of Amazon Cloud Services. So interesting thing. If you want to read about it, little article there. It's pretty readable. It's not too jargony, but that's the idea. Amazon kind of accidentally fell into it in the process of standardizing everything to work with, you know, untold thousands of vendors trying to sell stuff through Amazon. A couple big services in AWS. Number one, Amazon Simple Storage, which is also called S3. So it's a giant key value object storage system. Remember in one of our first NoSQL database things, we talked about the key value store? That's what it is. Last estimate I've seen holds about 5 trillion objects, and each object could hold up to 5 terabytes of data. So basically like a really big hard drive worth of data. The average is, of course, much less. So remember, key value stores, the key field uniquely identifies the record, and the value can be any sort of data structure. So you can have any number of different clients all storing data in their own unique formats. When they want to retrieve it from Amazon, they pull it out as one giant lump. Or they can also run queries on the data that are in there. So nice thing, it's cheap, it's reliable, accessible, which is what you should want. And it also does come with some analysis capabilities. For example, you can run queries on your own data that you have stored in there. Okay, it's not going to be quite as efficient as a relational database system, but it could be efficient enough. The other one, Amazon Elastic Cloud, or EC2. This is the core of what's called Amazon's cloud computing service. So in a sense, what it means, users rent virtual servers. So Amazon has untold tens of thousands of servers. Different clients can run different applications or store different data across a whole bunch of them. So typically it's not that a client says, give me 10 servers and I'm going to run all my applications on 10 servers and store all my data on those 10 servers. They get the equivalent of 10 servers of capacity and data processing throughout Amazon's cloud, right? So some applications, right, typically individual servers will only run one type of application. So if a client's running 20 different applications, each one of those could be on a different group of servers, right? And the data could be stored on separate machines in Amazon's database tier. So it's not like you're actually renting out 10 actual machines. You're renting out the equivalent capability of 10 machines. And it's sold in elastic compute units. That's the basic unit, which basically means Amazon has come up with a metric to say this is 1 unit of processing or storage or whatever else. Okay. So the nice thing, right, you can deploy applications in Amazon's cloud. So if you want to do transaction processing, you can do that. If you want to do some number crunching big data analysis, you can do that. If you want to run simpler, applications like, in principle, yeah, you could run Microsoft Office in there too, whatever. Anything you want to run, you can do that. But typically, Amazon's Elastic Cloud, you're going to do for those kind of things. And there's a lot of backup capacity. So Amazon's cloud is big. When they sense that traffic is starting to build up to dangerous levels, they'll bring on a new batch of servers to help handle some of that load. It is possible that even Amazon's cloud could get overloaded, but it's very unusual. Okay. So what you should know, right? Know what Amazon Web Services is, know what Amazon Simple Storage is, and know what Elastic Cloud is. Okay? Okay. So, talk about abstraction. So, cloud basically is a gigantic server cluster, right? We had our picture like a few lectures back. There were 3 guys on the left doing like web browsing and stuff, and then there was the cloud on the side. That was a bunch of different clusters of servers, and people accessed it through one standard interface, right? Which at that point was Facebook.com. So Facebook stores all user data on different machines. When users come, they all go to Facebook.com, and then they get directed through that interface to wherever their data is. Okay, so cloud instance, gigantic server cluster, can simultaneously support many different users, operating systems, right? Different machines can run different operating systems, support different applications, and they can run different applications that are not operating systems. So basically, in a sense, it's like a utility company. So with electric power, right? Anytime we want to charge something, get some power, we just go over and we put the plug in the wall and magically electricity comes to us, right? It's like magic. Kind of the same thing with a cloud. You know the cloud is there, you know it works, but instead of being a plug, there's some sort of web interface you go through. So you go to that particular web page, you access all your cloud stuff, and you don't need to know anything of the internals of how the cloud service is set up, right? Just like most ordinary people have no idea really how the electricity gets into their home, we just know that it does, right? Yeah. All right. And importantly, backup and recovery are automatic. That's a very standard thing for any cloud service these days. Maybe 2010, it should have been, but anybody that wasn't doing automatic backup and recovery, they're probably not doing cloud anymore because, yeah. Okay, so once upon a time, most organizations handled their own data. It was the way they'd always done it. When businesses transitioned from paper systems to digital systems, they already had all their papers under their roof, because why wouldn't they? If you needed to get them, you needed to access them right there. Once everything went digital, businesses still stored all their data under their own roof. So they bought a bunch of machines, right? A bunch of hard drives, a bunch of servers, whatever they needed to help people access that data, right? Key reasons, number one, business as usual. It was the way everybody always did it, and people don't really think outside the box that much. And the practical thing with that, if you're some, vice president of whatever, IT something, there's not a lot of upside, right? If you try to introduce some new technology and you say, we should really do this thing, if it works well, then okay, that's nice. But if it works badly, chances are you're out of a job, right? You're not going to get the full reward. If you save the business, $20 billion or $20 million anyway, you're not going to get that $20 million. You might get, at best, you might get a promotion a year or two down the road. They'll say, hey, good job on that one project, right? Whereas, if it goes under and you're like, that's your baby, yeah, you're kind of gone. So the risk is different, and a lot of people aren't really willing to stick their necks out for that. Number two, security perceptions. With some degree of validity, cloud was perceived as being a little bit insecure, so there was a big risk with that. And again, feed back into here, people say, wow, cloud thing sounds, in principle, we would like to outsource this network and data storage problem to somebody, but until they work out all the security problems, there's no way we're doing it. Other stuff, control over system design, people weren't, they knew they had everything, it was working well enough under their roof, there wasn't a good reason to go somewhere else. And accessibility. How do you get to the data? So think about year 2000, if you have like a 1 megabit connection, you're like a T1 line, that was like top of the line back then. That was considered pretty awesome. So again, if you have, let's talk about this for a minute. suppose your organization has, I don't know, 100 gigs of data, okay? Which could have been a lot in 2000, I suppose. Suppose you have that much. And suppose your connection speed is 1 megabit per second, okay? How long would it take to retrieve all your data if you needed to? Well, let's do some quick math. Okay, so 1 megabit per second, that's what you're getting. So 100 gigs equals 100,000 megs, and that's megabytes, equals 800,000 megabits. So you would need 800,000 seconds to retrieve your data. How many seconds are there in a day? This is basic stuff everyone should know. No? How many seconds are in an hour? 3,600. Okay? 3,600 times 24. What? Yeah, there you go, calculators, right? 86,400 seconds per day. So about 10 whole MFing days to get your data back. Okay? That is a long time. If businesses got to get their data, they don't want to wait 10 days to get it all. That's a big problem, okay? So until data speeds start getting really fast and like gigabit speeds become common, yeah, this is a big issue. Okay. And I'm going to get rid of that. Other problem, data continued to grow. So, now, growth is a nice problem to have, right? As problems go, that's the problem you want. Say, wow, our business is growing so fast, we're having trouble keeping up, right? It's a nice problem. But it does actually bring some serious problems. Number one, all the number crunching you're doing, it's going to start requiring a lot more computing power, right? If you have longer data and more variables over more customers, trying to process all that in big queries of databases, and the tables are spreading across machines, it's going to take a lot more work, okay? Another thing, there's a difference between storage and accessibility. Storage is easy, right? It's the difference between throwing everything in a garage and then closing the door and hoping you never have to go in there and try to find something, right? Storage is easy. Accessing something, and in particular being able to find the stuff that you need quickly, that requires a lot more smarter structure, okay? And everything else, backups, replication, relocation, consistency checks, making sure that everything's in one database is exactly the same as what's in another, all those are going to start occupying more system resources as well. Now, key thing, talk about this. Basic problem of utilization. Utilization means how much of the stuff you have, how much use you're getting out of it. For example, you could buy a really big house and use every part of it, and that's great. That's 100% utilization. Or you could buy a really big house and only ever live in the kitchen, right? You set up a bed in the kitchen and you live in there, and that's very low utilization. You're like, why did I buy this giant house if I'm just going to live in the kitchen? Okay? It's a similar problem with businesses. So, around 2000, maybe a business could handle peak traffic with 10 servers, okay? And most of the rest of the time, they're idle. So utilization, and this number is fairly typical, utilization might be 15 or 20% for the whole system, for the whole IT system, whatever it is. Okay? So that essentially means you buy 10 servers, but most of the time you're only using maybe 2 of them. Okay? Which means you have about 8 idle servers, typically. Now, 8 idle servers, you don't really want idle servers, but 8 idle servers isn't a huge cost for a big, Forbes 500 kind of business, right? It's not that big of a deal. But around 2010, maybe a business, same one, maybe that same business needs 1,000 servers to handle peak traffic. But the utilization remains the same, right? So something around 20%, okay? Which means you'd have about 800 idle servers. And that number is growing every year, right? So maybe you think that by 2020, you're going to have 80,000 idle servers. And you're like, shit, we can't afford that, right? So you start looking for a way to outsource the data management. And that's fundamentally what cloud is, okay? And this is why it happens. Businesses kept getting bigger. The utilization remains the same because they're designing their system to meet peak demand. But peak demand, by definition, is a rare event. Most of the time, utilization, your utilization of the system is a lot lower than the 100% or so, or 70% you might see at peak demand. And the problem is, with the volume of data involved, you have to add on more and more machines that are mostly just gathering dust. It's not a good way to go, right? So your big cloud providers like Amazon, they have this magic attribute with demand smoothing where basically, for example, if it's busy on one side of the world, it's quiet on the other and vice versa. And they have a lot of clients with basically uncorrelated data needs. So if it's busy for one business, it might be a quiet time for another business. And demand isn't perfectly smooth, but it's a lot smoother. And Amazon typically gets numbers like around 70% utilization for its system. So they can afford to sell you the service a lot cheaper than the business could provide it for itself because Amazon doesn't have like 80% of its servers lying idle at any given moment. Okay? All right. And that's a good break point. Questions on any of this stuff? Nothing? All right. That's all we got for today then.